And today I have the pleasure to present Glenda Hannibal. Glenda is a PhD student, third year PhD student in human-computer interaction from TU Wien, and her research focuses mainly on combining insights from philosophy and sociology with both theoretical and empirical work in human-robot interaction. Glenda holds a bachelor and a master's in philosophy and has previously worked as in the sociology department of the University of Vienna and as an expert for a new European Union project, HUMAINT. So today, Glenda is going to challenge our views and persuade us that we should put humanities into technology. And she will challenge our views of trust in HRI and attempt to reframe this discussion. So I'm very excited about this, and I'm looking forward to hear more about this subject. So the floor is yours, Glenda. I'm going to stop sharing.
All right. So I'm going to share my screen because I have prepared some slides. So can everyone see the slides?
Yes.
Great. Okay. So thank you for the introduction. I'm very excited about presenting my research on trust in HRI today for this Talking Robotics seminar. As you will see, my presentation will strongly reflect my background in philosophy and my experience with sociological theory and methods. Overall, my presentation will consist of both a theoretical and empirical part. In the theoretical part, I will shed light on my motivation to focus on the relation between trust and vulnerability to improve future research on trust in HRI. In the empirical part, I will show the results of 2 studies that I carried out to explore if people feel vulnerable after an instance of trust violation and to identify in which way robots can be considered vulnerable. To start out, I will show a short art performance to bring everyone straight into the topic of trust. I consider this art performance very helpful for understanding my philosophical approach to the analysis of trust, which also guides my research on trust in HRI. Okay, as we can see from this art performance by Abramovich and Ulay, trust is required under very specific circumstances. When there is a possibility of harm, aka the risk, when there is a future-oriented likelihood of that harm happening, aka the uncertainty, and when the exposure leaves people vulnerable. In philosophical terms, they are the preconditions of trust. Now, the value of studying trust in HRI is currently based on the argument that it will improve long-term interaction, collaboration, and engagement between humans and robots. However, since inappropriate levels of trust has been shown to occur in HRI, much work has been devoted to figuring out how best to strengthen trust by minimizing risk and uncertainty. When considering risk, the main approach has been to increase safety by addressing not only issues of physical harm, but also problems of data protection and discriminating biases. When focusing on uncertainty, the aim has been to increase familiarity by introducing more transparency or leverage anthropomorphic design. Vulnerability as a precondition of trust has been completely overlooked as something that could contribute to such efforts. As Schipola states, the hesitation to consider the relation between trust and vulnerability could be explained in terms of bad association, as, quote, vulnerability is not usually interpreted positively, particularly when related to design or engineering. These points also relate to concern about both social and ethical issues. For example, in the work by Turkel, we find a warning against the development of robots to keep children and elderly company because she argues that it might leave people vulnerable. Quote, technology is seductive when what it offers meets our human vulnerabilities. And as it turns out, we are very vulnerable indeed. We are lonely, but fearful of intimacy. Digital connections and the sociable robot might offer the illusion of companionship without the demand of friendship. Sparrow and Sharkey have been arguing in similar lines. They consider the care of children and elderly problematic when left near exclusively in the cold hands of robots, because it would leave them even more vulnerable on both a physical and psychological level. Given that robots developed for companionship bring up social and ethical problems, vulnerability in connection to trust in HRI comes to represent overexposure. It might therefore seem logical to argue that the design of robots that people can trust or consider trustworthy should be guided by the aim of making people feel less vulnerable. Metaphorically speaking, one could say that trust is an antidote to vulnerability. However, since vulnerability is conceptually related to trust as one of its preconditions, Middahl makes an important point when she writes that any attempts to avoid or eliminate vulnerability altogether will paradoxically also undermine the demand for trust because, quote, in the absence of vulnerability, trust is not required. I would therefore argue that it is important to challenge the negative view on the relation between trust and vulnerability for studies on trust in HRI. In fact, zooming in on vulnerability will show that it can play an active role in the positive reinforcement of trust between humans and robots. Vulnerability as a positive force for trust in HRI has already been suggested in current literature. For example, Martelora and colleagues found that when a robot expresses vulnerability during a learning task, this results in a higher level of trust and a sense of companionship. More interested in group dynamic, Sebo and colleagues found that when a robot expressed vulnerability during a collaborative task, the team members would display a higher level of engagement. Extending on this work, Traeger and colleagues found that the communication between the team members would improve when the robot provided vulnerability statements. While all these studies are important steps to the inclusion of vulnerability for trust in HRI, they also fall short in two regards. First, none of the studies provide any definition of vulnerability, but instead equate it to the errors or mistakes that a robot could make during interaction or collaboration. Secondly, reducing vulnerability only to a property of the robot's behavior fails to recognize that vulnerability as a precondition of trust must always be interpreted and linked to the specific situation or moment in time. As Kugelberg notes, vulnerability is relational because it highlights sensitivity to the ongoing and ever-changing relationship between humans and robots. So before moving on to the empirical part of my presentation, it is appropriate to provide a clarification of what I mean by vulnerability. Following Cipolla, I am defining vulnerability as the openness to harm. This is the most basic and general understanding, from which we can add questions about the different types of vulnerability and whether vulnerability must necessarily be tied to a subjective experience or not. So I have made this small conceptual model to make clear the relationship between trust and vulnerability. It shows how a high sense of risk and uncertainty results in vulnerability that instigate a demand for trust, which is based on the voluntary agreement to be open to harm. I am using this simple conceptual model as a reference point for my two studies on trust in HRI, because it enables me to generate two questions about the relationship between trust and vulnerability, from which empirical work is needed. Okay. Let me just see. I will wait a second. Yes, so sorry, I was just checking the slides. So before moving on to the first study, I will also mention here that if we consider this human-centered perspective on trust in HRI, we can infer from this conceptual model that to voluntarily agree upon openness to harm, one must feel or be vulnerable in the first place. The question that arises is if people do feel vulnerable in situations where they have to trust in robots or consider them trustworthy. So that's the basic question for the first study. Great. So the empirical work I'm presenting now has been a collaborative effort with Vicky Cerisi from the EU Commission and Astrid Weiss from TU Wien. Our work is currently under review. The aim of our proof of concept study was to empirically explore vulnerability and benevolence as two fundamental conditions of human trust in robots. But given the limited time, I will only mention our findings in regard to vulnerability. Our study was based on a near future application context of service robots helping out with the everyday activity of clothes shopping. We decided on this context after watching RoboLab demonstration video of the Pepper robot using both big data and an advanced recommender system to assist customers with selecting a fitting clothes item. Following Möllering, we use a methodology in which trust is considered a default state. From this socio-phenomenological perspective, trust is always already in the interaction, so that its measurement depends on an instance of trust violation. We created 3 different trust violation scenarios for clothes shopping that also formed our experimental conditions: economy, privacy, and transparency. By using the multi-dimensional measurement of trust questionnaire developed by Ullmann and Malle, and by adding 4 open-ended questions, our data collection and analysis rested on a mixed methods approach. While originally planned as an in-person HRI study, we ended up developing our proof of concept study as an online survey. Once people decided to participate in our study, they would first have to give us their informed consent. And with this consent, the participant had to fill in 2 pre-engagement questionnaires about their attitude towards robots and attitude towards shopping. When completed, they moved on to a small greeting session with the robot that was going to help them. In the engagement part of the online survey, we guided all participants through either economy, privacy, or the transparency scenario. To create a sense of interaction, we used in the engagement part expressive photos of the Pepper robot. In the post-engagement part, the participants had to fill in a questionnaire about the level of trust during the interaction for them to answer the open-ended questions about the experience of vulnerability, giving the instance of trust violation. All the participants were recruited through online posts on social media, mailing lists, or from personal contacts. So in total, we collected 98 validated service results across 3 different scenarios with a mean age of 36.46 years and a gender division of 42.9% of females and 52% of males. Regarding the statistical analysis of the trust questionnaire, we found that the experience of vulnerability did affect the trust ratings by the participants. That is, those who did not experience any vulnerability rated the interaction as significantly more reliable and ethical. This result is depicted in the graph you see. Concerning the content analysis of the open-ended questions, we found that some participants linked their vulnerability to a negative emotional state that they would experience during the interaction. The first quote reflects this interpretation of the results. Other participants connected their feelings of vulnerability with their perception of the robot's intentions. The second quote supports this interpretation of the results. In our discussion, we highlighted how our proof of concept study provided initial steps towards a new way of empirically explore trust in HI that uses the more ordinary, mundane, and familiar situation of clothes shopping. We argued that our study can be considered an alternative approach to current empirical work on trust in HI that draws upon insights from the rational choice tradition and from economic theories. In this paradigm, the experimental design centers around game scenarios, high-risk situations, and often amid the aspect of familiarity. As Salam and colleagues have discussed, using such experimental design contains methodological challenges because it is not possible to actually put people at risk. Now, our proof of concept study did not rely on such requirement, the use of game scenario, and we considered familiar situation as an important factor. To consider a more robot-centered perspective when studying trust in HI, we need to return to the conceptual model of the relationship between trust and vulnerability. Now, since robots cannot feel vulnerable, the relevant question that arises is how we can consider their vulnerability and how this is done empirically. The work I'm going to present now will soon be published as a late-breaking report for the 2021 HI conference that is taking place next week. The aim of my study was to gather knowledge about the various vulnerabilities of robots. On a methodological level, the use of expert interviews is important because of the ontological status of robots. Because robots do not have an inner life that connects vulnerability with feelings, experiences, or higher mental states, their particular vulnerabilities can only be studied from a third-person perspective. To paraphrase Latour, whose words about scientific facts are also relevant to this discussion, experts are simply needed because robots cannot, quote, speak for themselves. I therefore consider the specialized knowledge of roboticists as a vehicle to identify the specific robot vulnerabilities. Furthermore, as Musa and Nagel explain, Expert interviews is a good method for gathering a systematic overview of specialized knowledge domains. This was important for my study because I wanted to consider the various technical challenges when developing robots and to consider the types of vulnerabilities that are common across different application domains. I used a purposeful sampling method to recruit the experts where the selection criteria was based on whether they had a disciplinary background in AI or robotics, whether they had work experience in HRI or social robotics, and whether they had a research interest on the topic of trust. For the purpose of the study, it was enough if the expert would fulfill one of the criteria, while ideally they would cover all of them. So in total, I conducted 8 semi-structured expert interviews with experienced and leading roboticists living in Austria, the UK, Germany, and the US. Based on a verbatim transcription of the interviews, I used in vivo coding to summarize the exact wording, terminology, and formulations used by the experts. From few cycles of coding, the related codes were then lumped into 13 different categories depending on the content and meaning similarity. I then used thematic analysis to identify the common themes across the expert interviews. And you can see all the identified categories and themes in this figure. In the discussion, I showed how my results relate to broader debates on trust in HRI with regard to both conceptual and ethical challenges. As expected, some of the experts would comment on how to interpret the notion of vulnerability in relation to robots. One expert would ponder on the meaning by comparing the capabilities of robots to the more pop cultural representations, which is debated also in more general HRI research. Another expert explained the conceptual issues of operationalizing vulnerability, which is why a focus on risk is often preferred in current research. A third expert commented on the contextuality of robot vulnerabilities in relation to when and where it should or should not be considered beneficial. More interesting, I found that the category of malicious humans under the theme of people was among one of the most mentioned vulnerabilities, since several experts reported that people would intentionally be kicking, pushing, hitting, and attacking robots. An observation already highlighted in previous HRI research. Given that successful task completion by a robot or its operation depends on some form of mutual trust, it is relevant not only to ask if people can trust robots, but also whether robots can trust people. Questions about mutual trust in HRI leads to a broader discussion about how to deal with abusive behaviors towards robots, which Whitby has already recognized as a problem of ethics. Considering mutual trust that is rooted in a liberal tradition as described by Bayer, however, becomes challenging in the context of HRI because it presumes that the two involved parties stand in an equal moral and power relation. Since robots, according to Kugelberg, can at most be considered moral patients, and that they do not choose whether to partake in the interaction or collaboration, robots stand in an unequal position to humans. To address such issues, and with a focus on interaction design strategies for trust repair, Thalmeier and colleagues suggested that robots could use methods of apology, showing emotions, and involving authority figures. More concerned with ethical and legal strategies, Google have been asking whether to grant some form of robot rights as a contribution to current philosophical debates about abusive behavior towards robots. So, What is the contribution of all this work for future research on trust in HI, you might ask? I would argue that taking into account vulnerability as an active precondition of trust enables the inclusion of the more uncomfortable experiences, emotions, encounters, and dimensions of trust in HI in a way that does not only take vulnerability to be problematic. This is especially important when considering envisions of society where humans and robots are expected to coexist. So this is all for my presentation, and thank you for your attention.
Thank you, Glenda. I really liked your presentation. It brings some questions about how we should design our robots, and not only how we should design our experiments, so that our experiments are actually measuring what we want, and to see the effects of the robot's behavior in groups of people and dyadic interactions as well. I find it really interesting. I would like to know if, so perhaps if you could stop sharing your slides so that we could see everyone's face or names. I would like, so we could enter Q&A right now. So does anyone have a question?
If you have, just raise your hand.
Yeah, or write it in the
write it in the
chat.
I do have a question, but I don't know where the hands up is.
Just go ahead.
Yeah, sorry. Hi. Well, thank you very much for the presentation, by the way. It was really illuminating. And so what I'm thinking, and it comes as kind of a philosophy side of things. So what you were talking about when it comes to openness, it really did remind me of a philosopher of technology called Gilbert Simondon. And I don't know if you ever heard of him. And so what you were discussing was really interesting, because it was bringing a lot of things that I read from him about openness and indetermination. But then it's interesting because his perspective is how do we make a machine open from a design standpoint? So then the question to you is, do you think that the sort of framework that you're envisioning here is applicable in a design perspective? And when I say design, I mean computational and sort of architecture perspective, rather than an outside design. And then related, there's a second question. I'm sorry, like I'm gonna bother you with question after question. Is then the question of cultural difference. So is trust and vulnerability as openness to harm, etc., sort of a universal concept, or do you think there is space for cultural difference? And if there is, how do we encode that cultural difference within design and computation, if you agree with the first question that I'm asking? Sorry, it might be super confusing.
No, I think it makes perfect sense. So in terms of whether you can design or think this concept of vulnerability into how we develop robots, as I mentioned in the beginning of the presentation, there are a lot of efforts in computer science and HI, and also in software development, in which the focus is to kind of close this gap of being vulnerable from a system perspective. So you look into verification and these things. So I would say on a technical level, there are probably a lot of approaches you can consider. And I don't want to really go into details about that because it's not really my main focus. But there are people also here at the Technical University who focus on privacy issues, bias issues, and also the Internet of Things. How can we secure that people don't, for example, hack the robots that people use? but also regular safety issues of how can we have people standing close to a robot. And these things, of course, have to consider that there needs to be some flexibility in the design to have this human factor in it. But that would be a very technical question that I might not be able to really answer. And yeah, I mean, maybe some people can comment on that. And your second question was?
The second question was connected. It was about, you know, so basically what I was trying to ask is, if we realize that we need to actually work on the design, yes, and you know, and try and work towards openness, then how do we connect then the question of culture? You know, is there cultural differences in the way we understand vulnerability, yes, et cetera, and how is that reflected?
Yes, so that was about culture, right? And yeah, my presentation was focusing on a very general framework. So this is where my more analytic approach come in, because I'm interested, how do we conceptually consider these concepts and their relationship on a most universal level. So, and for this talk, I could only present this very small part on this relationship, but I also have developed a bigger model that is part of my dissertation, in which I will show also other factors, like how does all of this relate to the issue of trustworthiness. And here you can include aspects of culture, or also design in terms of appearance. And there's no doubt that when you go from this more abstract consideration to more practical level, you need to consider the context. You need to consider who are interacting with this robot. But it's not really an issue I will be doing in my PhD project. But I definitely think that this is the natural next step to consider. How do you then translate it into some kind of specific context? Because what I'm saying is, I'm just trying to generally introduce why this would be interesting in the first place. Yeah, I hope that.
Great, thanks. And no, very much. And looking forward to reading your dissertation.
Thank you.
Do you have any other questions? Please go ahead or raise your hand. If you have any. Yeah, go ahead.
Yeah, hi, I'm Alex. I really like the talk, and I really like the concept of vulnerability. But I'm thinking, like, in human interaction, so when you build the interaction with somebody, relationship, if you show yourself vulnerable and the other person does the same, you trust each other more, okay? But if the other person doesn't do it, you go back. How can you make a robot a bit more vulnerable? How can you make this not about privacy? It's not about hacking. It's more about a robot doesn't have feelings, so it cannot be vulnerable. What you're going to say? I can unplug the robot or kill the robot. That would be vulnerability. I don't know.
So my attempt was to, at this point, was to show that we can consider vulnerability in relation to robots as well. So it's mainly been related to security issues of systems before. And I want to show that it makes sense to talk about it also in HI. But of course, you're right. The premise is that if both parts shows vulnerability, or we recognize that they can, this is what is required for positive reinforcement. So this is what Brené Brown has been talking about. I don't know if you know about her, but she's a quite famous researcher, and who's also been looking into the aspect of vulnerability between humans, who says that yes, if we are all willing to do it, we can actually use vulnerability as some kind of power. And this is a very TED Talk kind of approach. And I wouldn't say that it's necessarily one-to-one with human-robot interaction, because you're right, it's not the same kind of reinforcement that we will see. So it's a very good question, and I'm still in the process of figuring out exactly how you can do this, how you can ensure that this vulnerability that we can interpret into a robot, because as you said, they cannot be vulnerable themselves, but that the way that we interpret the interaction with the robot somehow leaves this sense that this is a safe and neutral place in which humans and robots can engage. I don't know, was that satisfying or?
Yeah, no, it's satisfying. It's just thinking a bit more philosophical, right? So how, you know, you could make also like this part of the robot more vulnerable towards the person, like thinking, oh, maybe the robot will disclose a secret and that could make the robot vulnerable, right? You know, but
yes, so some studies, as I mentioned, there are studies that try to make the robot appear vulnerable by, for example, making these mistakes or saying, oh, this is not my day today, and give this appearance that it's not perfect. And research had also tried to show how imperfect robots influence likability and other issues. And there's no doubt that these strategies are worth considering, but it's also important that we have an appropriate level of trust so that we only trust robots that are actually trustworthy. So we have to really find a fine balance between the design of interactions with robots and then when does it change to perception or not. So this is also a very deeply philosophical, ethical issue that it's a whole discussion in itself, how to ensure that this design of the interaction is appropriate.
Yeah. Thanks a lot.
Yeah, so I'm sorry, I have a question. Following Alex's question. So from a practical, so I'm not sure if this is far-fetched from what what Alex was discussing, but I think it's not. So from a practical point of view, in social dilemmas, we have this problem, which is what is a consequence for the robot. Like we can say we can find good incentives and bad incentives for the human user, but while we can have good incentives for the robot, we don't have a way of inputting bad incentives. I mean, like what we would do, unplug the or do something to its I don't know, to its framework. So from this point of view, there is no vulnerability on the side of the robot. So when we design this kind of interaction, how could the vulnerability be designed as well?
Yes, so one of the experts I talked to, she was quite good at explaining that when you have a robot in a team context, there are a lot of factors involved. And here it's the interest and needs of many people in the team. And if you put in the robots, they also have to evaluate the interaction and situation based on what they can bring in to accomplishing a mission, for example. And while they don't have any maybe deep intrinsic motivation, like want to stay alive or something, if that's what you mean, or they have any high risks, like they don't have a concept of dying, for example, you might wonder what would it be. And I'm not saying that it's at all equal. Again, the vulnerabilities of humans and robot only partially overlap. So it's not about saying that they are the same and that they have the same vulnerabilities. It's about saying that there are that vulnerability is something we can say about both robots and humans, but that doesn't mean that they are the same. They're different, and we can rank them differently. So, for example, a robot in a military context might have to balance the goal of a mission with its own need for example, having enough energy or battery to actually also get the team to the goal and back safely. So it has to express, okay, I have these resources or not, and be part of this negotiation. And there it would matter for the team members to know if this robot is actually able to do this. So yeah, I would say that yeah, it's just important to keep in mind that I'm not trying to say that these vulnerabilities are the same, but this is also a lot of it's more work to also look into exactly those things. And I plan to make this kind of trust vulnerability metrics for one chapter of my dissertation, in which I will be more detailed about this.
Yeah, so I totally understand, but I think that's the key word, that intrinsic motivation that sometimes we forget in the design of the studies, and we're trying to replicate social phenomena, and sometimes there's something they're missing, and it can totally be this. So I buy it, your argument about vulnerability. So is there any more questions?
I think there's one in the chat. From
Barman Steffi asks, what makes a robot trustworthy?
Yes, so that's a good question. And this is the question when you study trust in HRI. So there are a lot of literature that looks into kind of the factors that influence human trust in robots. And this, I mean, you could make an extensive literature review. And most people use this framework by Hancock and colleagues, in which you relate it mainly to the factors that are influenced by the human, or from the robot, or from the context. And a lot of things have been studied, like the design, like does the anthropomorphic design increase the robot's perceived trustworthiness? Is it the performance of the robot? Is it its form? Is it its reliability? But also issues of whether whether providing good explanations would increase this trustworthiness. So this is a discussion in which you look at how does the design and performance of robots influence people, and you ask them then questions, either through standardized questionnaires or more open-ended questions, mainly self-reporting measurements, I think. And yeah, this is the majority of studies, but I have been intentionally not really looking into this, because this requires some kind of causal relationship between the trust people have in robots. And what my argument here is to look at the preconditions, but they don't have a causal relationship. So you cannot measure vulnerability directly. You have to operationalize it. So that's what I did, and by focusing on how people feel about it, or how we can consider robots open to harm. So just to say that it's a good question, and there's a lot of research if you're interested in, and a new volume, I think, by Nam and Leon, who just published a big collection about especially specific trust in HRI. And that's a good start to just jump into all the literature that has been done.
So I think we have other question here in the chat. I'm just going to read it. It's from Sandra Cano. She asks, trust can be considered an emotional process, but how is it possible to measure the trust between humans and robots?
Yes, so this is what I was trying. So trust is a lucid concept, and we know from sociology that it's an abstract concept. So if you want to capture it, you have to find out how to operationalize it. And people mostly do that by considering risk. So they say trust itself you cannot measure, but you can measure how risky people are willing to be in a certain situation. And this is exactly why game scenarios have been quite used, because it's a very easy way of framing what risk people are willing to take. So, for example, scenarios where you have to bet or you have money at stake or something, and you can then calculate quite precisely, depending on how much money people put in, this is translated into what is the trust level. But there are also maybe other ways to do it. And in my case, as I said, I tried to say my way of operationalize vulnerability, which is related to trust, or it's the precondition. I cannot study trust or vulnerability directly, both of them, because they are equally abstract terms. But I look at the feelings or the experience, the negative experience that comes as the measurement or as the operationalized version. And all, like with trust, you have to consider, let me see. Like what I then consider in relation to trust is the level of openness. So if you have this unpleasant experience, are you still able to engage in the interaction? Because it still has to be voluntarily. And if people withdraw, then you can say, okay, this is a sign that the trust level goes down. But this is a very technical methodological discussion. And as Salem discussed already back in 2015, it is also really difficult to make good empirical research on trust, because if you have to approve a study, you have to ensure that all participants don't feel that they are actually at risk or actually vulnerable. So you have to really be considerate about how to set up this study. And my first study that I presented was an attempt to say, could we still measure some kind of trust, even in such a regular, mundane situation? And I would say that we managed to at least show that it is possible. But of course, you would have to do more studies to see if we were just lucky, or if this could be a systematic approach.
Yeah, this has been a very interesting discussion. I feel bad for ending it, but I think just to be considerate of everyone's time, I think if there's more questions, we can continue the discussion in the Slack channel. So there's a channel dedicated to Glenda. So ask her questions there, and she'd be happy to answer, I bet.
You can also send me an email on my university address, or follow me on Twitter. Like, I'm also very present online.
Yeah. So before we finish, so let me just present our next speaker. So we'll have Niels Harberg from Farhat Robotics, and he's going to talk about the need for a human approach in technology. So this talk is going to be in 2 weeks' time, on February 19th. I don't have anything else to say, just to wish you a good weekend, stay safe, and see you in 2 weeks.